Hey, Algebra. Today we're going to talk about solving systems of linear equations by graphing. Let's go. All right, real quick, let's review how to graph a line first. Here we have our xy axis, or our Cartesian coordinate system, coordinate plane, okay, or our xy plane. All right, so I have this equation for a line. It's in slope-intercept form. Our slope is 1, it's m, and our y-intercept is 2, okay? So I'm going to go ahead in red and mark our y-intercept. That's the point where our line is going to cross the y-axis. It's at 2, and then our slope is 1, so I'm going to go up 1, over 1, and this is our next point. And I'm going to go up again, up 1, over 1, and I get 3 points. Now let's connect these lines. I'm going to do my best here to do it without messing up too badly. Okay. All right, so we found our y-intercept, which is 2. No, I thought I hit a button. And then our slope was 1. Another way to do this would be to make a table, xy values. So if x is 0, I plug that in, I get y equals 0 plus 2. That means y equals 2. And this is a point. This is our x-coordinate is 0, our y-coordinate is 2. And you see that if our x-coordinate is 0, we stay along the y-axis and we go up to 2. That's where we were. If our x is 1, let's find out what our y is. So if our x is 1, I get 1 plus 2, y equals 3. So our y-coordinate is 3, and that's where this point is, right? Let's see, right here, okay? So I can find the y-intercept, go up 1 over 1, go up 1 over 1 continually for the slope, depending on what the slope is, or I can make a table over here. Plug in an x value right there, and then solve for y, okay? So we have 2 equations now. How do we graph 2 equations at the same time? Well, first let's do equation 1 in red, and then equation 2 in blue. So our first line has a slope of 1, y-intercept of 2, so it's the same line we did last time. And I'm going to try to carefully draw my line here. Okay, and then in blue, my y-intercept is 3, but my I have a negative 1 slope, so that means I go down 1 over 1, down 1 over 1, down 1 over 1. So I'm going to draw a line here. This might not be the best example. My lines are not exactly straight. Let's see if we can fix that. Okay. All lines are straight, but it's not the ones you do freehand. Okay. So what do we have here? We have 2 lines, and they cross at this point here. That looks like it's at the point 0.5 and 2.5, okay? Which is a bad example. I tried to avoid using fractions, but the concept is the same here. What does this mean? What is the point where they intersect, all right, where 2 lines cross? What does that mean? Well, that means that this point right here exists in both lines. So for our first equation, if x is 0.5 and I add 2, right? What does y equal? Y equals 2.5. And for our second equation, I'm going to do it in blue. If x is 0.5, add 3, I get y equals negative 0.5 plus 3, y equals 2.5. So what this means is, I'll do it in black, that the point 0.5 and 2.5 is a solution to both of these lines. It is a point that exists in both lines simultaneously. It's at the point where they intersect, which means it's a solution to this system of equations. Okay. And so we find it by graphing and finding when those 2 points cross. All right. What does it mean to solve a system of equations? Well, a system of equations, I'd like to change colors. Sorry about that. A system of equations is really when I just have more than one linear equation. So in this case, I have 1, And then I'm going to switch to green. I have 2 linear equations. So there exists a system, or excuse me, there exists a solution, some point. Actually, we'll call it xs and ys for solution. This point will exist in both of these lines. It'll exist in both of those linear equations, okay? So we're going to graph the first one, 4x plus 3. So my y-intercept is 3, my slope is 4. So I go up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And then I'm going to go back 1 and then down 4. 1, 2, 3, 4. Because if the both directions are negative, I'm moving the right way. Just want to make sure I don't mess up the slope here. 1, 2, 3, 4 over 1. Okay, so let's connect these lines. Oops, I missed that one. That's all right. Now we're going to graph the line number 2. So my y-intercept is here. It's at 1, -2. I go up 1 over 1, up 1. I go backwards, and I go down 1 over 1, down 1 over 1, down 1 over 1. Okay, and so I'm going to draw my line as straight as I can. Okay, my hand's not super steady. I suggest you use a ruler for these. Okay, so it looks like they intersect right here. Well, in theory, they should be. And that's the point -1, -1. So this should be a point that exists in both lines. It solves both of these equations. So we'll use red. If I plug in for my first equation a -1 for x and solve for y, I get -4 plus 3. I get y equals -1. And that's true. So I use -1 for x, and I got -1 for y. So check, that works. Switch to green. Y equals -1 minus 2. That's y equals 1, right? Negative and a negative turns it into a positive. Minus 2, this is y equals -1. So again, I have -1 for my x, which we plugged in, and I got -1 for my y. So this point here is a solution, meaning it fits into both of these equations. The input -1 gives me the same output for these 2 different lines. Now to sum up, what's the form of the equation for the lines we're going to use? We're going to try to make sure all our lines are in y equals mx plus b, slope, intercept form. Okay. We're going to make a table for each line if we need to, or we can use the y-intercept and the slope to make our lines, whichever works best for you. Then we plot our points on the y-axis and the x-axis, sorry, x and y-axis, or our xy plane. We find where they intersect, and then we write the solution to this as a set of ordered pairs. So we have our x-coordinate for the solution and our y-coordinate for the solution. This is the point where those lines intersect. Your assignment is going to be the solving systems by graphing worksheet. Find it in class or online. And code word is house. You need to come and tell me this word. Write it down in your notes. That way I know you watched the end of the video. Have a great day. Good luck.